Good morning, everyone. Let's slowly start with our web data harvesting workshop. I hope it will be lots of fun. And we'll start with an introductory lecture where I'll explain to you what it is, why we need to do that, and what are different methods and stuff. And then we will continue with some practical tasks and exercises. So, as I know, in the previous 2 days, some of you took Python workshop and some of you took R workshop. And what I will be showing to you will be mostly in Python, but don't worry, we will manage that, hopefully. And could you please raise a hand to those who attended our workshop so I know roughly how many of you are here? Okay, so a little bit less than half. But yeah, feel free to ask questions. I'll show you some maybe concepts in Python before we start. So hopefully you won't get very lost. So yeah, my name is Marija Isupova. I work as a software engineer in NATO Strategic Communications Center of Excellence. And this is basically a think tank where we do some research related to what people do in social media, how different governments and militaries are communicating with them. And part of my work includes collecting data from social media in order to analyze that. So I'm doing some of these things that I will be telling you today in daily life. And apart from that, we are not so many technical people there in the center, so I'm doing lots of different programming-related jobs and lots of different programming languages. So yeah, that may be a bit chaotic, but all in all, I know some things about web data harvesting, and I will tell you about them. And this is very introductory level, so this is a huge topic where you can go deep into details, and afterwards I'll give you some pointers in which directions you may look if you want to learn more. And feel free to ask questions. As I understand, my email was sent to you because I already received some questions, which is great. And if they won't be answered today, I'll reply to all these questions later. So let's start. Hopefully, more or less everyone is here. And let's start with the question, what is data harvesting? So, in very general words, it's the process of getting data and information from the online resource. And it could be done in many different ways. So, for example, the easiest one, you can do that manually. And it's not necessarily the worst case, because if, for example, you have a news website and you have some comment section and you need to extract comments for one particular article, and there are not that many comments and it's a one-time job, it probably would be easier for you to just copy these comments somewhere into Excel spreadsheet and analyze them, rather than writing some complicated programs for that. And so, yeah, sometimes there are situations where manually doing that is kind of easier than using all those cool technologies. But I know that it may be tempting. Sometimes I also had some cases where it could be solved very easy in 20 minutes by copying and pasting, and I spent 2 hours writing a web crawler for that. Don't do that. And the other way, which I will be talking about and showing you today, is using an API, application programming interface. So what it is, I will tell you in the next slide, but it's basically a way to extract the data that some software or a data provider is willing to share with you, so it usually is easier than writing some complicated software. The other one is using a web crawler. So what it is, again, we will talk later, but essentially it's just extracting data from the web page as you see it. So it involves a little bit of programming, and I will be showing you today how to do this in Python, but you can do it in R as well if you feel more comfortable with R. But yeah, unfortunately it would be too difficult for me to show it in 2 languages simultaneously, but just as you know, it's also possible. It's also possible in a lot of different other programming languages. There are libraries for that. And I'll briefly touch upon it as well. You can also utilize different data collection services where someone is handling all of that for you. You're just paying some subscription fee, for example, or one-time fee, and you don't need to think about how to extract this data at all. So let's start with an API. So API stands for Application Programming Interface, and essentially it's a way for software to communicate with other software. So each time you're using an app like Facebook, you send an instant messages, you're logging in somewhere, you are using an API. So you're sending some requests to the server, you are sending some data, you're sending your login information, and you're expecting an answer. So that's a way how software is communicating with the other software. And why does it matter for us in this web data harvesting context? So an API is a way for this software to share some data with us as well. So for example, I'll show you some examples of what it is. So if you have some database that collects some news data, for example, they may have an API which makes your life easier. You don't need to go to the web page, you don't need to extract this data, you're just asking this provider what exactly you need, and they are sharing this information with you. Of course, it also can be a paid service, it can have some limits, and so on. But yeah, essentially, what you need to know, that's a way for software to communicate with other software. And you don't really care how this API is implemented, you just need to know how to access it. So how to access it? So the anatomy of API call looks something like this. You have something called endpoint, which is on the left. So you know where should you go to ask for some information. So this is an example of Wikipedia API call. So here we are asking Wikipedia to share with us some information. And we are using one of these endpoints, depending on which information we may need. And we have some parameters. So we have a query, so we are asking Wikipedia to show us article, to share with us information from article about Latvia. And we can have some different other parameters, like share with me the title of this article, share with me links that this article has, share with me the text of this article, and so on. So this is the way how you form this API query. And when you send this request, when you're asking Wikipedia to return to you some data, you get a response, which may look something like this. So this is one and the same response, formatted in two different formats. Usually it's either JSON format or XML. So what you need to know about that these are two different ways how to share the data in standardized way, let's say. So it's the same response, but in JSON it's key value pairs. So you have status, that is okay. You have result of this user. It has ID, name, and email. And in XML, it's the same information, but you see that there is opening and closing tags. So there is much more text in XML response than in JSON response. So usually, API providers return to you information in JSON. And we will see how it looks in reality. But yeah, just for you to know, these are different ways how the API may return information for you. There could be many, many more ways, but these are two, like, let's say, that you see most often in the wild. And yeah, I mentioned these query parameters, and one of them that you will see quite often is an API key. So API provider may ask for you to authorize yourself, and yeah, it signs for you something like this big string. It's a random string. It's not an API key for anything. So yeah, so basically what you do with this key, you attach it to your request as a parameter, and that's why API provider knows who you are. And for example, if you have paid subscription for something, they know how many requests you did and whether these requests should be limited, and so on. And of course, if you have an API key, you should keep it private because it authenticates only you. And even if it is paid, then if someone knows your API key, then may use you whatever you are paying for, which is not very good, of course. And so that's just for you to know. We won't be using any API keys today, but if you will be interested in looking into different, some other APIs, apart from what we will see today, you should know that this API key stuff exists. So, and the last theoretical thing about API is that there are 4 main ways to interact with this web server API provider, not only API, with the web itself. There are more of them, but we're not interested in them right now. And actually, today we will be looking only at the GET request. And what it means, it's a way of saying, hello, web server, please retrieve and get me this information. So, for example, and this, again, API call, what you're doing here, you're asking Wikipedia to retrieve some information for you. So I'm interested in an article about Latvia and its title, please give me that. So you are sending a GET request. And also, usually, very often, you see post request, which is when you're sending some information to the web server. So for example, if you are typing your login and password and trying to log in some website, you are sending this post request. So what you should know, a GET request doesn't make any changes to the database, to the data which is stored there. You are just requesting for information and you may only read that. So you're not doing any bad with this GET request, you're just asking, please show me this and that. And with post request, you do modify database, so you should, so it's basically a request which is saying, please store this information in your database. So you may want to be sometimes careful with that. But again, we won't take a look at them today, unfortunately, probably won't have time for that, but again, just so you know. And the other 2 that are most often used are put, which is a way for the server to ask, please modify this information. So for example, if you are trying to change your email address at some website, you are sending probably this put request with the request to change the information and delete. Yeah, it's just asking for delete something. So let's see some examples, because I'm talking a lot about that in theory, how it looks like. So APIs usually have a documentation. 1 second. Yeah, so I'll try to make it bigger. Hopefully you see something. So yeah, this is a snippet of Wikipedia's documentation. It's quite a complicated API, so I don't recommend it using as your first. But yeah, so these are all these endpoints that you may query. So you see, if you want to get something from English Wikipedia, you are going to this address. If you are trying to get something from MediaWiki, you're going to this address, and so on. And yeah, there is documentation which describes how to use all of this stuff. You see, it's quite big. There are a lot of different stuff. And this is the format here you can ask the data for. So yeah, as I said, there is this JSON and XML, and you see there are like all these different formats you may do. And the example of this request may be, for example, this one. So you see, it's you're going to this English Wikipedia endpoint, and there are some parameters. So I'm asking to parse, which means to basically retrieve the information from this Latvia Wikipedia page in JSON format. And oops, I closed everything. So this is what this query returns to us. So I'll make it bigger. So this is the response in JSON format. So you see that I asked for the page with title Latvia. It has an ID. It has the text, which is an HTML format, not really readable, but this is the whole text of this Latvia Wikipedia page. And you have links that this page contains. So you see there's like lots of information, and you may use it somehow in a way you see fit. So yeah, this is an API example when you ask this Wikipedia server, please return me the information about some article. So yeah, it has some images, and yeah, you generally see that there is a lot of information there. Some may be a little bit easier, maybe, and with less parameters is the Star Wars API. So here is the information about people, films, species, planets, and all this stuff from Star Wars movies. And here is also an example how it may be used. So you see that this is the endpoint, this swapi.def.api. This is an endpoint, and you specify what exactly you want to request. So what I want to pay attention here, that you see that this request is in different formats. So you don't have this question mark and parameters. You have all these parameters in this basically request string. So let's try this people one, and it requests, it returns the information about the Luke Skywalker character. It has name, it has different other parameters like hair color, skin color. You see that there are, I don't know, I hope you see that there are links on the other endpoints, like films where this character appeared, and yeah, vehicles, starships. So it has link to other information in this API, in this database. So, and of course, you can also request it in the JSON format. I'm sorry, I don't know why I'm struggling so much with the presentation, but yeah, this is how this JSON response may look like. And actually, my browser is making look a little bit more nice. And actually, what the server returns to me is something like that. So it's not formatted, but it still have these all fields, like name is Luke Skywalker, you have height, you have mass, and so on. And yeah, this just looks a little bit nicer. So this is the other example of an API, and the information you may get from there. And the third one I want to show you is a random dog image API. And you see that, how do I get my presentation back? I don't know. Anyway, so yeah, this is an API that requests a random dog image, and you see that it's formatted in yet another different way. So you have this API endpoint, which is dog.ceo/API, and it returns to you a link to a random dog picture. So you don't only need to get some maybe textual information, you can get some image links and so on. And yet again, all these requests can be formatted differently, so consult the documentation about how they should look like. Because yeah, for example, in Wikipedia, there is lots of documentation which describes how exactly you should format these requests to the API provider. So I'll try to get my presentation back. Here it is. I'll manage. Yay. So the other API that I wanted to tell you about is called the GDEL project. So this is the global database of events, languages, and tones. Yeah, so, no, sorry. Yeah, this slide. And yeah, this is a global database supported by Google Jigsaw. and it has broadcast, print, and web news in more than 100 languages. So we will try to extract the data from this database in the practice tasks. But I think, as considering the theme of this summer school, I think it may be useful for you to use this database. And we are using that at work a lot as well, because it's updated very quickly, and you have lots information there from different countries, which could be super useful. And unfortunately, the very API is not so good, but there are different services that provide unofficial APIs to GDELT where you can extract this data. So the very interesting feature of that it, of course, it has a lot of news articles which you can search for, but it also extracts entities from each article. And by entities, I mean that it extracts people that were mentioned there, locations, organizations, and so on. So basically what it means, you can ask GDELT to give you all articles where this person was mentioned. And you can create connections between different articles. So, for example, this person is mentioned in articles about certain topics, and you may create some different beautiful graphs of how it may look like. So, yeah, it's a really cool database, which we will take a look in more details in the practice section. But what you need to also know that it's really huge, so it's more than 2.5 terabytes of data, which maybe it's not that much. Hard drive space is not very expensive these days, but what you need to know that if you are trying to interact with this data somehow, so let's say you have this hard drive and you downloaded this, and let's say it's a big file, then it's very hard for you to actually interact with that. Because if you try to open it in Excel, for example, it won't be able to do that. If you try to load it into Python, you also won't be able to do that, because you need a lot of RAM for that. And that's why it's more convenient to use API, and there are lots of official and unofficial APIs for GDELT, and I'll show you all of them later. But yeah, GDELT is a cool thing. So you may ask, why we are not using APIs for everything then? Why do we even need web scraping? The problem is that API may not exist, or it may not be useful for your purposes. Very often you see that the API does not have proper documentation. So the API exists, and as I said, that you need to go consult documentation about how you need to format your requests in order to receive the data you want, and it can be quite tricky to figure out, and if the documentation is not there, it's very hard to use this API. So in these like in these cases, you may consider using some other methods. Sometimes the website is just very small, and the developer, the owner of this website, didn't have the infrastructure or resources, or maybe they just didn't want to create an API. There are some limits on the API. So, for example, if you are scraping some, for example, if you have some paid API, or not even paid, just sometimes even free APIs have some rate limits. So, for example, you may do only 100 requests in 1 hour, for example, and you need to do more, then you may have a problem with this API. So, yeah, APIs are generally good, and you want to use them, but sometimes you just can't, because of all these things I said here. And if API is not usable, then we may consider using web scraping. And web scraping, again, very general definition, it's data gathering from the web by any other means that are not interacting with API directly. In practice, what you do, you take an HTML document and extracting some information from it. So this is the super simple HTML document. So what HTML is, it's the way that the server, the website, is telling your browser how it should look like in your browser. So you have tags which describe this layout to your browser. So you have this general HTML tag in which everything is enclosed, and you have this title that you see, this simple HTML title on this tab. So I'm saying the web browser by this title tag that please render in this tab title this simple HTML. Then I'm asking to the browser to render H1. H1 stands for heading, and there are like from H1 to H6, which are becoming smaller and smaller. H1 is the bigger one, the biggest one. So I'm asking the browser to render this hello world, and then to render a paragraph which says this is the test page. So this how this web page may look like. Of course, in reality, they are a lot more difficult, and again, we will tackle in practical tasks how to do that. But generally, what you are doing with web scraping, you are going to this page, and you're thinking that, okay, I want to extract this information from the heading and from the paragraph, and you are saying your web scraper that I want the information from the H1 tag, and it returns to you this hello world. And I want the information from the title. It returns you information from the title. So the web scraping is the process of extracting from this HTML code the information that you want to store, analyze, and so on. But yeah, as I said, these web applications in the real world doesn't look, unfortunately, like that, because then it would be very easy to scrape them. Right now, in reality, browser users see some combination of HTML, CSS, and JavaScript. And HTML is the skeleton I showed you, so it's just the way to tell the browser that this element goes after this element, after this element. Very, making these things like describing it in a very primitive way, but still it's generally this skeleton of web application. Then you may have some CSS, which is basically styling. So you're saying that browser, please make my background red and my text purple, whatever, but it doesn't really change the behavior of the application. But JavaScript does change the behavior of this application. So when you see all those beautiful buttons you may interact with, you are using JavaScript under the hood. And what you should know from this, that JavaScript can, but not necessarily does impact web crawlers. So JavaScript these days is like both blessing and a curse, because these days, websites are often received by the browser in something like this way. So you have, of course, it's again making things easier. There is a bit more of information, but the concept is generally the same. So you have this wrapping HTML tag, and you have one element, essentially, which is called div, which denotes the block of HTML, and it has ID root, and you have a bunch of JavaScript files that say, okay, render, basically show all the information in this root tag, and it all gets created dynamically. And of course, it makes work for developers easier. So you have all these modern tools, modern frameworks, how you can program all this stuff, how you can make everything responsive, and how you can interact with these buttons, and everything works, and everything is nice. But for us, as people who are doing web scraping, it may become a little bit of pain, because it's quite hard to extract something from this HTML file in the left, because there is no information here. It just gets rendered dynamically. And in reality, as I said, JavaScript can, but not necessarily does impact web crawlers. For example, if everything gets immediately rendered in this root element, then basically what you see in the browser, everything the web crawler can also see. And that's not a big of a problem. The problem is when the content of the website is somehow dependent on what you're doing there. So the biggest problem that I usually encounter is endless scrolling, which is not necessarily endless, but basically you need to scroll the page in order to see more content. So for example, you go to the news website, you see some page, there are some, 10 or so articles, but in order to load more, you need to scroll the page. And there are ways around that, but yeah, it's just not that convenient, unfortunately. And yeah, you have all these forms with them with which you need to interact. For example, if you want to log in, it again becomes a problem. You have different pop-ups and alerts, which requires you to click something. And as a lot of content these days are generated dynamically, they also have some automatically generated IDs. So You can't just go and say, retrieve me all the elements with this ID, because this ID is generated automatically, and the other time you reload this page, you have another ID. So again, there are ways around that, but you should know that it sometimes may become a problem and make your life a little bit more painful, but yeah, what you're gonna do. And yeah, there are different ways how you can do this web scraping. We will be doing this using Python, and Python, yeah, can be used very nicely and conveniently to perform different web scraping tasks. And there are most popular libraries, which are Beautiful Soup, and this is like the oldest and the most low-level library. We won't be talking about that today, but if you will be interested in learning more about web scraping, I strongly suggest to you to look into this Beautiful Soup library, because it basically teaches you how to do all these things from scratch. So what Beautiful Soup does, if you have an HTML web page, it helps you to extract some information. So it's an interface for you to say, Python, please extract to me information from this H1 tag. Please extract for me information from the paragraph, and so on. So yeah, it's very low level. You are like interacting only with HTML content, and you still need to do some requests to the web page and receive response yourself. And to help with that, there is a Scrapy library, and we will be using that today. And it's an open source web crawling framework. And what I mean by framework is that it handles a lot of these repetitive tasks under the hood. It generates requests, fetches responses, it's process these responses, so you don't need to think about how do I go to this web page, how do I extract this information, how do I store it, and so on. Scrapy handles all of that for you, which is really convenient, really cool, so that's why we will be using that today. Basically, I can say to Scrapy that please go to this list of pages and do some stuff there, and I don't need to worry how do I programmatically do that. And of course, Scrapy isn't a mind reader. You still need to define to that what exact data you want to extract, to give it locations, to give like URL patterns, but still it provides a clean framework to keep your code organized. And the other library worth mentioning is called Selenium, which is actually not specifically Python library. It's a set of tools for web testing initially, but you can also use that to interact with the web page. So if you have this problem with JavaScript, when you need to do something in order to get more content, scroll the page, for example, to get some content, you can use Selenium for that. You can use plain Python for that as well, but it's quite painful, so I recommend using Selenium for that. And we also won't be using that today, but I'll show you in the end where you may look like if you're interested in that more. But generally, if you want to interact with the web page, Selenium is a way to go. And yeah, as I said, there are libraries in R as well. So I was using a long time ago the library which was called RWest, I think, so like harvest. So yeah, for example, if you are all of your code is in R, if all of your data processing pipelines are in R, then maybe it would be more convenient for you to use this libraries that R has. But you can also extract some data in Python, store it somewhere, and process with R. So yeah, there are different ways how you may go around that. But just for you to know, yeah, it's not Python-specific problem. You have these capabilities and libraries in a lot of different programming languages. I just think that the Python is the more convenient one, so that's why I'm teaching that. And when you scrape this data, you need to store it somehow. And the easiest way to store the data is in a CSV file, which stands for comma-separated values. So in the first row, you have column names. So for example, you have ID, name, and email. And yeah, basically, then you're describing in the rows, it's in an order. So it's very easy to import it in Excel, for example, or in Google Sheets. And yeah, it's very convenient. If you have small amounts of data, you may import it in Python or R to work with that further. So yeah, if you don't have lots of data, it's a quite convenient way to do that. And today we will be storing data specifically in CSV files. And in the end, you will need to submit your task also in a CSV format. But for example, what to do if you have all of this GZEL data, which is 2.5 terabytes. And as I said, you can't really open it in Excel or import in Python or R. So then you can use databases, such as MySQL or MongoDB. And if you're new to databases, I know that installing a database may sound a little intimidating, but actually it could be quite as simple as installing just about any other kind of software. And what is the main advantage of the database? That it provides for you a convenient way to interact with the data. So for example, you may have this query, and what is asking is select all the data from the table named users, where in the column name there is a string John. So you don't need to upload all these terabytes of data in the memory of your computer. You just have database in which it is stored in optimal way, and it is specifically optimized to do these sorts of tasks, and you can quite quickly interact with this data and retrieve that. And yeah, all the data which you are interacting in the API is probably stored somewhere in this databases. Again, we won't be doing that today, but if you one day end up with a big amount of data from, let's say, different news websites, you may want to store it somewhere. So don't be afraid maybe to try databases for that. And last, but definitely not least, is about ethics of web scraping. So there are different gray zones regarding web scraping. And the first thing you need to do that web scraping may violate the terms of service of the websites you are scraping. So, for example, you can't scrape Facebook. Well, you can do technically, but if you will do that, they probably will discover and ban you quite quickly. So be careful with that. So there are probably no law enforcement for that. Again, I'm not a lawyer. If you are doing some web scraping for your company, please consult your lawyers. I can't give you legal advice. But generally, it's nothing illegal. It's just that websites just don't want you to scrape them, and you may ban you for that or ban your IP address. The other thing, which is more about, being a nice person, be nice with the service of the websites you are scraping. So consider different scenarios. You, for example, have a web crawler that goes through some, local, small Latvian website, and it wants to aggregate some of its data. So in this case, you probably want to do it very slowly, maybe even overnight. So you want to disrupt the server of this person, because if you start bombarding it with requests, maybe it just won't be able to handle that. So maybe you want to consider being nice with them. And the other thing is that the other case, if you want to scrape hundreds of different small websites and get small subsets of its data, maybe it's not bad if you just do it all at the same time, because these are websites on different servers. You are not disrupting any of them, just getting data and going out of there. So it's not that bad if you send a lot of requests in the short amounts of time, if you are not doing this constantly. And the third case, which you probably encounter the most often, is that you have a web crawler that traverses a very large site, such as Wikipedia. And even if you are sending hundreds of requests per second, Wikipedia probably won't notice that, because they already have a lot of traffic, and maybe you shouldn't worry that much about what you are doing there. But still, this is the thing to consider when you are doing web scraping, whether you are not loading the server, you're scraping too much. And I have an anecdotal story. One of my my very first web scraping job was related to scraping Baltic website. And after we started doing that, I don't know whether these events were connected, but after 2 weeks or so, they introduced CAPTCHA on their website. So after 10 requests, you should have solved the CAPTCHA, and then you could continue scraping. Again, I don't know whether these two things were connected, but I don't know, maybe they indeed noticed a lot of activity and decided to do something with that. So yeah, if the website you are scraping is not particularly large and don't have many requests, just don't bombard it with the requests, just for the sake of being nice and for the sake of not being banned and for the sake of website owners not introducing some security measures. The other thing that you should be careful about, you should respect the privacy of the people whose data you are scraping. And here in European Union, you have GDPR, which, in my opinion, again, if you are doing web scraping on scale in your company, for example, consult your lawyers. But what is that? But as far as I know, the GDPR is only a thing that relates to scraping and limited somehow in European Union. So you should not store the personal data of people on your computers. And for example, if you have some comment section where you have a username and email and a comment text, the email probably would be considered personal data. And first you should think whether you need it at all. Probably not, then you can just not collect that. And if you are collecting this data, then you should think about how to encrypt that. In case this data gets stolen or something like that, you should not expose personal data of different people. So again, be careful with that. If you are scraping a news website and there are just titles and news texts, it's nothing bad, but if there is a comment section with some emails or I don't know, I can't from the top of my head come up with some example, but yeah, be careful with that. And it's quite a great area what specifically is considered the private data, personal data, so emails usually are considered. So again, be careful with that. And generally, the rule of thumb is if there is a usable API, use an API. It will be easier for everyone. And the last note on this topic, there is a thing that is called a robots.txt file, and almost every website you will encounter of the web have this. So it's usually it's probably always located on the website's root. So for example, nwikipedia.org/robots.txt. And it's a way for the website to say, please don't go to these sections of the website, please don't scrape it. But there is no way to enforce actually a robots.txt file. It's just a way to websites to put the sign, like, please don't do that. But there is no way to enforce that. And let's take a look at some of them. So this is how Wikipedia's robots.txt look like. I hope you see something. So you see it's a very, very long document, quite long, that describes all these use cases. And the structure generally is as follows, that this file describes user agent, so it's a specific bot that they are addressing. Usually it's search engines. For example, if a search, there is probably, oh, there is not. So they're addressing different search engines that they allow one search engines to search specific sets of set of pages and don't allow to other search engines to search. Like basically, this is a way to talk different search engines what they specifically should or should not be doing. And okay, Wikipedia's one is quite big. Let's take a look at, oh no. Let's take a look at delphi.lv. Robots.txt file. So this is user agent, this star, and star means all. So they're addressing all bots and automated web crawlers that may end up on their website. And they're saying, please don't scrape our comment section. Please don't scrape our like different I don't know what any of that means actually, but yeah, for example, newsletter, please don't go there, and please don't extract information from here. But you may extract the information from any other pages. And here you can see that they are talking to this Petalbot, which is, quick Google showed me that this is some Chinese search engine, and they're disallowing them to scrape any of the data on their website. So this is, the slash means all the pages on the website. And yeah, so before you start scraping, check the robots.txt file. What is it saying, whether it's allowing you to scrape what you want to scrape. And the last example, let's take a look at Facebook's robots.txt file. And yeah, again, they're talking with the Apple search bot, and they're not allowing them to scrape different pages. And yeah, but generally, Facebook doesn't allow to scrape anything at all. You see there, I don't know, yeah, user agent star, so for everyone, disallow scraping anything. But again, it's more like a recommendation. It's a way of the websites to ask, please don't do that. But there is actually no way to enforce that, fortunately or unfortunately for us. And let's practice now.